we close out this section on visualizations that are used to show changes over time by looking at the slope chart. It's one of my favorite graph types to use for these particular data. And to help us understand more about the slope chart, we have Francis Gagnon, the founder of Voila, an information visualization company based in Montreal. So I'm going to hand it over to Francis so you can learn more about the slope chart.
Oh, hi, Mr. Schwabish. Thanks for having me on your program. And hi, everyone. My name is Francis Gagnon. I am an information designer and the founder of Voila, an information design firm based in Montreal and focused on sustainable development. You can find us online at chevoila.com or on pretty much any social media. We're here today to talk about slope graphs. They are simply horizontal lines representing quantitative data with a focus on their beginning and end. You can read them on the left, looking at the clustering or the outliers in the data. You can do the same thing on the right. You can be reading in the middle to show trends in the data, such as this one exception that goes down in this example, or of course, you can read each of the slopes. You can be fancy with your data, with your slope graphs. You can add colors to make an example. You can add labels and axes and grid lines. As long as you keep horizontal lines and a focus on the beginning and end, you still have a slope graph. The first type of slope graph would be a simplified line chart. So in a line chart, of course, you see data series changing over time. In the case of a slope graph, you would be focusing on just 2 points during that time. Here is an example that I like about power generation in the USA, developed by NPR. It starts in 2004, ends in 2014, overlooks the 9 years in the middle, and you see the change from 51 to 40% of coal for power generation, and increase in natural gas and in renewables. But be careful with your slope graphs. And here's an example that I made up. It looks like everything is increasing equally. And that is true if you're looking at the absolute change. Everything in this example has increased by 10. But think of the relative change. The one at the top went from 200 to 210. And so that is only a 5% increase. But at the bottom, going from 20 to 30, that's actually a 50% increase. So remember that slope graphs are not good for comparing relative change. If I had done the same thing in bars, it would be very different. Your perception would be that the long bars have a much smaller relative change than the black bars. Let's go to a real-world example. This compares population in selected countries between 1960 and 2013. We're going to be comparing Japan at the top and Australia at the bottom. The slope for Japan is much steeper, but actually the change is relatively smaller by a lot. In Japan, the population increased only by 37%, but in Australia, it increased by 130%. So remember that what increases more is not what increases faster. Now, this is a limitation of slope graphs. Let's look at an opportunity. You don't have to use straight lines. In this example, what if we actually show the details of what happened between those 2 years? We still have a slope graph because we're using horizontal lines and we are focused on the beginning and end. But now we have a richer story of what's happening, for instance, in Russia and in Japan. Another type of slope graph would be a bump chart, but simplified. A bump chart will show the change in ranking over time. Here's an example from the world of Formula One. This is the Monaco Grand Prix, one of the most prestigious and most boring sporting events in the world because it is very hard to pass in those city streets. So this is how the official body of Formula One shows the race, with a bump chart that shows the position of each pilot at each lap. But it shows a lot of extra information that is not very consequential, such as the pit stops that don't change much anything, and it overlooks something very interesting that happened in 2018 in this example. It's this driver here that started at the back and ended in the middle at the very end. So if we use a slope graph to show this race, it becomes much more obvious that there was an outlier. And in this case, we highlighted it with colors. So Verstappen started very last and ended ninth, and he passed a lot of drivers, something that appears to be very difficult, especially when you look at the top 6 that was the same at the start and the finish. The final example of slope graphs is simplified parallel coordinates. So parallel coordinates do not show time on the horizontal axis. It shows different categories. And here we reduce it to simply 2 categories. Here is an example that compares a subset to the total. This is an example with employee feedback. On the left-hand side, you have the feedback for the whole organization, and on the right, the subset only for the sales team. And it becomes very apparent, for instance, that career development is a bigger issue in the sales team than in the whole organization. The slope graph does a very good job at this. Here is another real-life example that I like because it shows that you can have fun with a slope graph. And if you look here, you have completely different categories on the left-hand and right-hand side. On the left, you have annual expenses per capita in health for different countries, and on the right, life expectancy. So you see that one of the countries, the US in this case, is very different from the others. But one thing that is very important to keep in mind is that each individual slope is meaningless. Japan did not increase from $2,700 to 80 years of life expectancy. The only thing that you can read is the general trends in the data in the middle. So that covers the slope graphs, and I hope you'll have fun with them.
And thanks to Francis for that great review of the slope chart. As you can see, it's closely related to the line chart, to the bump chart, to the parallel coordinates plot. And you can go through the rest of the videos in the One Chart at a Time video series to learn more about each of those different graph types. But you can also notice that there's a lot of considerations that you can keep in mind when creating this type of chart. So this is going to wrap up the section on visualizations that are used to show changes over time. And tomorrow we're going to come back and move into another category of data types. So make sure you come back, check it out, and subscribe to the YouTube channel so you can get alerted about each of the new videos. And see you tomorrow.